Hello everyone. We're going to be doing number 4 from the course reader, which is on page 12. It says a protein was completely digested with arginine C, an enzyme which cuts on the C terminus of our residues, and and an internal peptide, i.e., not derived from the N or C terminus, was purified. Determine its sequence from the information given below. Amino acid analysis of 1 mole of the peptide yields 3 moles of cytosine, 1 mole of methionine, 3 moles of lysine, 1 mole of arginine, and 1 mole of tryptophan. Treatment of the intact peptide with trypsin gave rise to 3 different products: a dipeptide containing arginine and tryptophan, a dipeptide containing lysine and cytosine, a tripeptide containing cytosine, methionine, and lysine. When the intact peptide was treated with Sanger's reagent, FDNB, the hydrolyzed with the acid, the derived products were DNP cytosine and mono-DNP lysine. Treatment of the intact peptide with cyanogen bromide produced a pentapeptide containing cytosine, methionine, and lysine, and a tetrapeptide containing arginine, lysine, tryptophan, and cytosine. Let's focus on number 1, yeah? Okay. So the way I like to do these is I always like to kind of do everything from what I know. These questions are a lot about what you don't know and trying to make it into what you do know. Hopefully this will become clear as I go along. I answered a lot of these questions by saying a lot of these amino acids I get by what they don't tell me. And that's just kind of by assumptions and stuff like that. But you have to be careful because you do have to assume right. So this is going to be 3 cytosine, 3 lysine, 1 arginine, 1 tryptophan, and 1 methionine. So if we look at these and we add all these up, we have 3, 6, 7, 8, 9 moles total, which gives us 9 letters. I'm going to go ahead and write our letters down here. So this means we're going to have C, 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 K, 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 W, R, and M. So these are all the amino acids that we could have. The very first clue is very, very critical. It says that it cuts, this reagent that we have that makes this, cuts on the R terminus, the C terminus of the arginine residue. So our very last amino acid must be arginine. And that's from part 1, without not even getting to the A. Okay. Part 2 tells us about, or part A tells us about this, which is good information. Part B says treatment of the intact peptide with trypsin. So trypsin cuts after any R's or K's. And what does this trypsin do? It produces a dipeptides containing WR, dipeptides containing CK, and dipeptides containing methionine, cytosine, and lysine. Okay, well, if we count up these, right, we have 1, 2, 3, 4, 5, 6, 7. So we're missing 2 amino acids from this analysis, from what part B tells us. Now we know that from part A that there's only one W and one R. We also know that there's 3 C's and 3 K's. Down here, there's only 2 C's and 2 K's, 1 methionine, 1 W, 1 R. So this one must be doubled. So this is actually what we have. We're just not able to see it because it's duplicated. Okay, but this also tells us something else. A dipeptide here is going to give us our W there. And a lysine must be here because it must cut after here. Because once it cuts after here, you produce this dipeptide. This is the only way this can be arranged, because our R must be the last one. So now we've figured out 3 amino acids. We know where this one is. We don't need to worry about that anymore. We know where one of our K is. We still need to find 3 cytosines, 2 lysines, and 1 methionine. Part C says when the intact peptide was treated with Sanger's reagent, F, D, and B, the hydrolyzed with acid, the derivatized products were DNP cytosine and mono DNP lysine. So that means that our very first our first amino acid is going to be this one. And our second one is going to be lysine. Why is that? Well, if you look at the way that FDNB reacts, is it will first attach, and then once hydrolyzed, you'll cut off the first amino acid from the N-terminus. This attaches to the N-terminus. When you hydrolyze it with acid, it cuts off that first one. But what's going to happen is when you use acid again, it's going to release that and actually reproduce some more of this, which will allow it to rebind to the next amino acid. And that's why you get a lot of cytosine and then one mono DNP. I'm sorry, not one, but this is why this is not mono and this is. Because this is your second amino acid, because you haven't hydrolyzed this with acid yet. If that doesn't make sense, there's still other ways to figure this out. But what to recognize from this is that cytosine is going to be your very first amino acid. And then your second one, your very last clue, is that treatment of intact peptide with cyanogen bromide produce a pentapeptide containing cytosine, methionine, and lysine, and a tetrapeptide containing these 4 amino acids. I'm really sorry. What does that mean? That means that in order to produce a pentapeptide, methionine either has to be 1, 2, 3, 4. It could either be here, because this will be 5, or it could be here. However, there's a clue here that that the pentapeptide contains cytosine, lysine, and methionine, and the tetrapeptide contains tryptophan and arginine. So what does that mean? That means it must cut here to produce a 4 amino acid peptide chain with tryptophan and lysine. What that also tells us is that cytosine is in here too. So cytosine must be this one. Methionine must be this one. So we can erase these. And we're still left, so now we have all this, right? And we have cytosine, lysine, which is 2. We found all of our 1 amino acids. We're still missing 2 amino acids. And we're still missing a cytosine, lysine. But however, down here, our dipeptides, we're missing one of these too. So that means that in order to produce 2 peptides from part B, this exact configuration will produce 2 peptides, or a dipeptide containing cytosine and lysine and nothing else. It will also produce a tripeptide of methionine, cytosine, lysine, and dipeptide of tryptophan and lysine. If you go back and you look at all these right here, whenever I do this, I always start from the very beginning once I have my sequence, and I make sure that everything makes sense and that everything fits. So this means that R is in the very end. This means that my mole concentrations is 3, 3, 1, 1, 1, 3 cytosines, 3 lysines, 1 methionine, 1 tryptophan, 1 arginine. This means that 3 products, a dipeptide containing arginine, tryptophan, a dipeptide containing lysine, cytosine, and a tripeptide containing cytosine, methionine, and lysine. So if it cuts after if tryptophan cuts after, what's it called? Trypsin, not tryptophan, sorry, trypsin. It cuts after every K and R. When it cuts after R, it doesn't produce anything new. It cuts after K, 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 and it's going to give us exactly what we predicted down here. Number C says, talks about the Sanger's reagent, which gives us a C and a K. And part D lets us know that it's going to cut after methionine and producing a tetrapeptide with tryptophan and arginine in it. So all that makes sense. And hopefully this will make sense to you. And I'll be posting another one about the Garrett and Grisham number 2 on page 124, chapter 5. Hopefully that will help you out. A lot of this, again, is just producing what you, or not producing, but trying to figure out what you don't know and what's not being said. Because a lot of this, not everything's going to be told to you. You got to kind of try and use some logic to figure that out.